All right, here we go. We're back and we're going to be talking about optional braces in this one, and then we'll dive into logical operators. I'm ultimately going to probably do this satisfaction scale in a separate video because I think we're going to end up spending a good amount of time here on logical operators. I don't want the video to get too long, but let's get into it. We previously looked at the syntax of an if statement and an if else statement, right? We have heads on both of these. Inside the head is a condition on both of these. This else clause is ultimately optional. The thing that I kind of want to look at is these braces. In practice, if statements and if else statements commonly contain only one statement inside of their respective bodies. Like most control statements, okay, we got this category of control statements. If statements is the only control statement we know thus far, but next unit we're going to learn two additional ones, loops, a while loop, a for loop, and all of those fit in this category of control statements. The braces that indicate the body of an if statement, those little curly boys, can be omitted if the body contains only one statement. These two statements are functionally equivalent, right? On the left-hand side, I have an if statement. It says if x is greater than or equal to 7, well, we're going to sout. We're going to system.out.println, lucky. Well, inside this body, right, the body is designated by these curly braces. There's only one statement here. What this is saying is that those are optional. On the right-hand side, I have effectively the exact same thing. There's no braces, and this one statement will be considered the body of this if statement. Okay? The same thing can actually occur on an if-else statement, right? If age is greater than or equal to 18, we'll say we can vote. Otherwise, we're going to say we can't vote. Well, each of these respective bodies, the if body, the else body, they only have one statement in it. These braces are ultimately optional. On the right-hand side, I have the exact same thing, just no braces. Omitting the braces on a single statement if statement can help reduce some of the brace clutter in your code and increase readability, but you need to be careful. Omitting braces can be prone to error. Whatever immediately follows that if statement, whatever is the first statement that occurs after a header with no braces, will be considered that structure's body. Let me show you what I'm talking about. Okay, I've got max of 3 here. Just like all the other ones that we've coded, our if statements and if else statements, they only have one statement inside the respective bodies. Right, so this if statement, right, there's the one statement. I can get rid of these braces. Notice IntelliJ is happy with me. There's nothing perfectly wrong. In fact, you can mix and match like this. I don't recommend that. You kind of want to be consistent. In practice, if you were to ever get a job, they will tell you what they prefer. Most actually prefer that you leave in the braces. And the reason being is it makes it easier to edit code in the future, right? If I want to add more statements to this if statement, right, and I come in here and I add more statements, we add a random sout to our code that says, hello world. Well, as we're going to see, this gets a little bit tricky, right? This else is mad at me now because I effectively have two statements inside of this if statement. In order for me to basically make that work, I need to add the braces back in. Okay? It's easier to add the braces when you're originally writing the code than it is to actually come back in and insert them. So most styling guides that I have seen actually say just always leave the braces, but they are optional. This if statement only has one statement, so you can get rid of them. This else also only has one statement, so you could get rid of these braces. And so we end up with something that looks like this, and to me, this is like way cleaner, right? Our if and else statements, they're simple thus far. They only have one statement in them. Now, this is made clean thanks to we're still using proper indentation, right? This line is indented to clearly show that it's in the body of this if statement. If I were to say, come up with some crazy indentation, right, the readability starts to decrease. In fact, we could do something really wonky like this, and that works, but it's definitely not clean. Okay, so I'm going to back it up. Where this gets kind of prone to error is maybe down here. This is a pretty good example of this, right? I'm going to get rid of these braces. They're optional. There's only one statement in the body of this if statement. Max is equal to z. Okay? what the slide said is whatever the first statement that occurs after the if statement will be considered the body of the if statement, right? This is it. This is the body of the if statement. But where things could get kind of iffy is, let's say I bring in an SOP, hello world. I'm even going to indent it. With the indentation, the way this reads is if z is greater than max, well, we'll set max to z, and then we'll print out hello world. But this hello world should only happen if z is the maximum. Right? That's what the indentation is showing me. Let's actually try it out. I'm going to run my program. The thought is, with this indentation, is that we'll only get hello world if z is the maximum. So I'm going to put in a test case where z is not the maximum. All right, just 5, 8, 3. Notice we still get the hello world. Right? In this case, y was my maximum. What's going on here? Well, as the slides indicated, whatever the first statement is after the if statement, when there's no braces, that is the body of the if statement. This system.out.println line, despite being indented, is not even in this if statement. What this really looks like is this. Right? When I indent it like this, it's very clear that the hello world has nothing to do with this if statement. But if I indent it like this, it's a lot less clear. Okay, so that's kind of where like losing braces can be prone to error. And again, most styling guides, like if you go get a job at Google, they're going to tell you just leave the braces in no matter what, that sort of thing. But I do think it lends itself to cleaner code. I have traditionally done this, trying to decide if I'm going to move away from it or not. But what I see right here, this is a quiz or test question for sure. This SOP is not even in this if statement. So watch out for that. Okay, with that in mind, right, we learned that our braces are optional. We're going to move on to logical operators. So decision making is often way more complex than what a single relational operator can handle. Real quick, there's 6 relational operators. Can you name them? We should have less than or equal to, less than or equal to, equals, and not equals. For instance, age isn't the only criteria required to vote in the United States. This is very topical. Let me close out of Teams before something crazy happens. And Discord and everything else. Okay. Age isn't the only criteria required to vote in the United States. You must also be a U.S. citizen. The decision logic required to vote in the United States is more on the lines of if age is greater than or equal to 18 and you are a U.S. citizen, where U.S. citizen is a Boolean variable. Okay? Java has included 3 logical operators to make more complex decisions. We're going to have or, and not. Here we see these 2 guys. The name of this is literally vertical bar. You Google it, you say, what is the name of this guy? And the Google says this is a vertical bar. It is above your enter key, shift, and shift backslash will give you this guy. This little guy, the ampersand, right? Most people know this one. This one's shift 7 will get you that. And then lastly, this exclamation mark is just called the not operator. So there's the 3. So the AND logical operator will evaluate to true if both sides of the operator evaluate to true. For example, here I have a int variable age with a value of 20. I have a U.S. citizen variable with a value of true. Note that it's a Boolean. We say if age is greater than or equal to 18 and you're a U.S. citizen, you can vote. Otherwise, you can't vote. Well, age is 20, right? So we see 20 greater than or equal to 18. This left-hand side of my AND logical operator is true. U.S. citizen also has a true value. What I have is true and true. This particular little segment of code would print that you can vote. This if statement was true, so we would skip the else. All the possible outcomes of a Boolean expression can be mapped using something called a truth table. Okay, so this expression, right, this is effectively the left-hand side of my AND logical operator. Are you 18 or older? This column is basically, are you a U.S. citizen? The right-hand side of my and logical operator. And this last column is the result of this operator, right? When you are 18 or older and a U.S. citizen, you can vote. When you're 18 or older but not a U.S. citizen, you can't vote. If you are not 18 or older but you are a U.S. citizen, you still can't vote. And lastly, if you're neither, you of course can't vote. Now that's kind of logical with just the expression we got going on, but ultimately, like, I could just reduce this to column A, column B, the result of column A and B. This is a truth table for the AND logical operator. And what I want you to notice is that the only time we get a true value, the only time, is if both sides are true. If either side is false, or if both sides are false, we're going to get a false. Additionally, logic gates can be used to visually express this. Right? This is ultimately what the AP CSP exam ends up using, is this visual representation of logic gates. It looks something like this. Right? Logic gates are super important when it comes to like electronics, for instance. So what I have are two inputs going through an AND gate, and then I'm going to have some output. Right? If I have true and true, this gate produces a true value. If I have false and true, well, one of my sides is a false value. I have false and something, we're going to get false. If both sides are false, I'm going to get false, right? So the only time I get a true value with an AND is if both sides are true. The OR logical operator will evaluate to true if one of the sides of the operator evaluates to true. So in this case, you only need one side to be true, not both. Let's take a look at an expression. We have two Boolean values, right? So the left-hand side could be a Boolean, the right-hand side could be a Boolean. In this particular case, weekend is true. Holiday is false. So what I have is true or false. Well, this OR logical operator is going to produce a true value overall, which means this if statement evaluates to true, which means we would enter the body, we would print off zzz, we would skip our else. Here's a truth table for this expression, and I'm just going to jump straight to kind of this because really this is the one that's important, right? It doesn't matter what the expressions are. Left-hand side, I'm going to have some Boolean value. Right-hand side, I'm going to have some Boolean value. Ultimately, all logical operators are going to produce a Boolean value. Take a look at our truth table. When we have true or true, we get a true value. When we have true or false, we get a true value. When we have false or true, we get a true value. So anytime one of the sides is true, the result is true. The only time I get a false value with the OR logical operator is if both sides are false. Okay, same thing, we could have logic gates, again used in electronics, in order to kind of make this decision. If I have true or true, I'm going to get a true value. If I have false or true, doesn't matter, one of my sides is true, I'm going to get a true value. The only time I get a false value is if both sides are false. Okay, what's kind of cool about these logic gates and what ends up happening in electronics is that they get combined in order to make more complex decisions. So let's go through a couple of these, and I can actually just type into these text boxes some potential gates, right? What I want to know is, what is the outcome, the overall outcome? Right, so over here, the left-hand side for this AND logical operator is whatever the result is of this AND logical operator. Let me show you. We have true and true. That's going to produce a true value, giving me down here true and false. Right, I have an AND with a false. The overall result is false. Okay, let's maybe switch this up a little bit. Now what do we get? We have true and false. I'm going to get a false value on the left-hand side over here. I have false and true. Well, I'm going to get a false value here. Okay. Now, what if these are ORs? Exact same combination, but we got ORs. I have true or false, giving me a true value. We'll have true or true. Well, that's going to give me a true value. Now, these things can actually be combined, right? I'm not limited to only ands or only ors. We could do something like this. What's my result here? Well, we have true or false, giving me a true value. I'm left with true and true, giving me a true value. What if I flip these? What does that give us? I have true and false. This is going to give me a false value, leaving me with false or true. That's going to give me a true value. Right? True or something. It really doesn't even matter what that something is. I have true on one side of an or operator. This will actually always give me true. It doesn't even matter what this gate is over here. Okay. Where I think these start to get interesting is what if you know the outcome, right? But don't necessarily know what one of these values is. I'm going to maybe get rid of this guy and switch this guy to a false. And I want to know what goes here to give us a true value. Okay, you could try plugging in some stuff, but I'm actually going to kind of work in reverse here with this particular one. I know in order for me to get a true from an OR gate, I need at least one of the sides to be true. In this case, I've got a false over here, so this side has to be true over here. My left-hand side has to be true in order for me to get a true value. This is an AND gate, an AND logical operator, so the only way I'm going to get a true value out of it is if both sides are true. So I would need this to be true. True and true gives me a true value. I have true or false, that'll give me a true value. Okay, let's see what we got. Let's back it up. What would this need to be in order to get a false value out of the whole thing? Right? I have an OR and I have a false value. In order for me to get a false value out of the OR, both sides have to be false. Well, I've already got a false here, which means I need this side to be a false value. I've got a true here, and with AND, all I need is one side to be false, and the whole thing is false. So this is a false value. True and false gives me false. False or false gives me false. Okay, let's switch things up a little bit. I'm going to delete that guy again. Do an OR. Do an AND. Now what's the question mark? Again, working backwards. My overall result is false. I have an AND. Well, AND produces false values as long as one of the sides is false. Well, this side is already false. And it seems like it doesn't matter what this side is. Okay, why don't we try plugging in a true value? If I have true or true, this is going to give me true. I'm left with true and false, which gives me a false value. But what if it's F? I have true or false, which gives me a false value. I have false and false. That gives me a false value overall. So in this particular case, it could be true or false. Does not matter, really. I've got this false and something. I'm always going to get false out of it. Okay. Let's see. What do I have? True or... Oh, no, I wanted it to be that. Okay. What is this now? I have an AND logical operator, and I need to get a false value out of it. I have true and something. In order for me to get a false value out of the and logical operator, I just need one side to be false, meaning I need this side to be false. Okay, the problem is I have true along with an or. It really doesn't matter what this is. I'm always going to get a true value out of this, meaning I'm going to get true and true no matter what. So in this particular case, there is no outcome. This isn't possible. Okay, what do I mean? Well, let's actually plug in values, right? If this is true, I've got true or true, true and true. That's going to give me a true value. So that doesn't work. What if this is false? I have true or false, which is going to give me a true value. I got true and true, which is still going to give me true. So in this particular case, this one is not possible. How about an X? The last one I'm going to do is, let's kind of maybe wipe this a little bit. What if I want to know what gate gives me this outcome? Okay. Working a little bit backwards here. I need a false value. I have true and something. I need this side to be false. In order for me to get a false value here, well, if this was an or logical operator, I'm going to get true every time. I've got true or something. It really doesn't matter what this something is. This will give me a true value every time. True and true doesn't get me there. What about the and logical operator? If I have false and true, this gives me a false value. False and true would give me a false value. So the answer here is going to be our and logical operator. So you can see how those can get combined, and you can really just keep going with this. The AP CSP exam is usually only going to combine about 2 gates maximum for their multiple choice questions. So let's leave this clean for Miss Vu. Okay, the last logical operator we're going to talk about is just the not, right? This exclamation mark. And it is used to invert a Boolean value. Let's take a look. Here I have a Boolean variable with a value of false, right? When I get down to this if statement, it says if not done. Well, the value of done is false. What the not logical operator does is it inverts a Boolean value, right? So the opposite of false is going to be true. This if statement is true, and so we're going to actually print off keep going, skipping the else. Okay. Not can be used to kind of change expressions. The left and right hand side are actually the exact same, right? Are you old enough to vote? Right? Is your age greater than or equal to 18 and you're a U.S. citizen? Okay, then you can vote. If your age is not greater than or equal to 18 or you're not a U.S. citizen, this is technically the same thing. You know, we'll come back to this. This is a bit much right now. The not operator can sometimes be used to write more elegant conditions and increase readability. And with that, we're going to stop there for this video. I'll see you in the next one where we're going to code satisfaction scale using our logical operators.